How can embedded C control physical devices? Imagine a tiny computer inside a washing machine or a drone that makes everything work smoothly. That's what embedded systems do, and embedded C is the language that helps make it happen. When you think about controlling physical devices, it's all about telling microcontrollers what to do. Embedded C acts as the bridge between software and hardware, giving precise instructions to sensors, motors, LEDs, and switches. Microcontrollers are small chips with built-in processors, memory, and input-output pins. Embedded C programs are written to tell these chips how to interact with the outside world. For example, you can write code that reads data from a temperature sensor, processes that data, and then turns on a fan if it gets too hot. This process involves directly accessing hardware features through special registers inside the microcontroller. These registers are like tiny switches that control specific parts of the hardware. The first step in controlling devices with embedded C is setting up the microcontroller. This means configuring the input and output pins, timers, and communication ports. You tell the microcontroller which pins are connected to sensors or motors and set them up for reading or sending signals. Next, the program reads inputs from sensors or switches by accessing specific registers that hold their data. For digital inputs, the code checks if a pin is high or low. For analog inputs, it reads voltage levels through an analog to digital converter. Once the inputs are read, the program processes this data using simple logic. It might check if a sensor's value exceeds a certain threshold or if a button is pressed. Based on this decision, the code then controls outputs. For example, it can turn on a motor by setting a bit in an output register or adjust the brightness of an LED by changing pulse width modulation signals. These signals are generated by timers inside the microcontroller, which are also controlled through embedded C code. Timing is very important in embedded systems. Sometimes you need to wait a specific amount of time before turning on a device or to synchronize actions. Embedded C uses delay loops or hardware timers to manage this timing accurately. Because embedded C is close to hardware, it uses bitwise operations to manipulate individual bits in registers. This allows for precise control over hardware features without wasting resources. Embedded C is designed to be efficient and straightforward. It uses data types that match the hardware, such as fixed-size integers, and provides functions to access special function registers directly. This makes controlling physical devices fast and reliable. You can find embedded C in many real-world applications. It controls household appliances like washing machines and microwave ovens. It manages automotive systems such as engine control units and airbag deployment. It also drives robotics, where sensors and motors work together to perform tasks. Mobile phones and printers also relying on embedded C to handle communication and device management. In summary, embedded C controls physical devices by giving microcontrollers the instructions needed to read sensor data, process that data, and send signals to actuators. It manipulates hardware registers directly, making it possible to create efficient, real-time systems that interact with the physical world. This close connection between software and hardware is what makes embedded systems so powerful and versatile in everyday life.